It's him, and it's her. It must be MathsAt. Usual disclaimer applies. Don't trust anything we say, and please don't sue us. We haven't got anything of worth anyway.
Hello. It's been a while, hasn't it? So we are MathsAt Easter.
Yay!
Joining me now and forevermore is the cracking Ben Parker and the excellent Hannah Veal. How are you two?
Hello.
Oh, we're straight on the egg puns, and there'll be many more of those, I'm sure, before the night is out.
I mean,
Yes.
I've only got two and I'm out. I'm done.
Yeah, it's no yoking matter.
Oh, you beat me to it.
Oh, I'm so sorry.
You're too quick. I've lost. I've got nothing now. I've got nothing.
Oh, happy Easter. Happy Easter.
Happy Easter, everybody.
To let you behind the curtain here, we're so bad at getting together that we're actually doing this at the end of January.
Yes, we are. I love Easter. I mean, because Christmas,
it's certainly Easter if you look in Tesco's.
It is. Yes. Easter is you have no responsibilities. You don't have to go and see the mother-in-law. You don't have to, buy lots of presents. It's just sit and watch James Bond and have lots of chocolate.
I mean, you can tell who hasn't got any children, can't you, in this?
So you increase childcare at Easter means less happier Tom and Hannah.
Yeah, well, it's a kind of it's a mixed bag Easter, because 2 weeks holiday is quite nice if you've got something really nice planned, and we haven't at the moment, but we might do eventually. But no, my kids are we've been really, really low key on Easter thus far, so I'm not even really sure they know it happens. They certainly don't know it's a chocolate thing.
Oh,
really?
Well done, you played that.
No, not yet. Maybe they will yet this year, but we certainly haven't pushed the chocolate thing on them. So to them it's just school holidays, and it's great.
But so we're going to be talking about Easter. Well, at least Ben is, I think. I mean, you think there's a lot of maths around Easter, so shall we go to the math zone and
let's go straight to the math zone. I don't think there's any other zone to go.
Or all this excellent maths you're going to show us. Have I already done that pun? I think I have. Oh, well.
Yes,
To the math zone!
The math zone! I wanted to start with a very simple question. Okay? Tom,
Okay.
Hannah, you're both educated people.
Oh,
Hannah, slightly more. What
Debatable.
date is Christmas Day?
Okay, so I'm going to, do you have like a klaxon in QI or something? Is
No. Not what date is Christmas Day?
What day is Christmas Day? 25th of December.
Excellent, very good, well done. And what date is New Year's Day?
1st of January.
Very good, Hannah. What date is Easter Day?
Oh, who the knows?
Exactly. Okay. And that is the whole point of today's episode, because what I wanted to do is talk about the algorithms of life. Okay. And I'm going to try and convince you of my thesis before the night is out, before the podcast is out.
Please start at the beginning.
The algorithms are both the most wonderful thing to happen to the human race and will be the thing that absolutely destroys us, and nobody can do about them. So, for example, we could have a simple rule, which is, take your age, add the digits together, multiply it by 9, and add the digits together. So are you doing it in your head?
Oh, go! We have to do this now. Oh. How old am I?
Okay.
Right. So add the digits.
Yes.
What was it? But plus 9 times 9. What was it?
Well, take the digits of your age and add them together.
Yeah.
Yeah.
Add them together.
Mm-hmm.
Multiply by 9.
Right.
Yeah.
Right. Add the digits of what you get together.
Yeah.
Right.
Yeah.
Take away 4. Try this at home. readers, try this at home, listeners, rather.
Right.
Yes.
So take your age, add the digits together, multiply by 9. Yeah. Take away 4.
Right.
You've lost me already. I need to write this down. I'm terrible at mental arithmetic. I'm terrible at it.
Guys, he changed it halfway through anyway. So
yeah, and also,
it's been the same.
Also, I was at 0. So then you said like multiply it by 9, and I'm like still at 0.
Yeah, exactly. Yeah.
Oh.
But I think I went wrong somewhere.
0.
You can't, if you add the digits of your age together, you can't have 0 unless you're
See, I told you I was
0 years old.
I mean, so far,
Where
then,
were we?
proven that none of us can follow a recipe. I think that's
Right. But, you know, algorithm, if your child's temperature is above 39 degrees, call the doctor. Right?
Good.
If it's below 32 degrees, call the lawyer. I mean, I don't know. Okay?
Call a mortician.
Yeah, exactly. Well, we got onto child murder very early tonight, but here we go. But I mean, that's an algorithm, okay? If something happens, do something. It's just a series of steps from going from the start to something to the end.
Yeah.
All right. And Easter is a very good example of an algorithm. So,
okay.
Well,
I thought it was just to do with. Is it not to do with the lunar calendar?
Well, it is. Okay, this is where things get complicated.
But before we get complicated, though, why isn't it like a Christmas or a New Year's Day where they say 12th of February? Hey, that's Easter, whatever it is.
Well, we'll come to that. And the problem with that is religion. Okay. And the real problem is the Christians.
Please send all hate mail to Ben Parker at maths@gmail.com.
So, when was the Last Supper?
Last night.
Passover.
Exactly. So it was a nice Passover meal. So Jesus and his 12 finest friends sat down to a nice meal. And some stuff happened. You can all read about it. We'll put some citations in the text below. Reference 1, the Bible. So what they want to do, the people that sort of organize these religions, is to have Easter Day on the day 2 days after Passover. Okay, but the problem is
Passover changes every year as well.
Right. So our calendar, the sort of Christian calendar everyone basically uses nowadays, is a solar calendar.
Yes.
And the Jewish calendar is a lunar calendar, which is absolutely great because the Jewish calendar essentially has extra months put in, so it stays at vaguely the right time of year. Basically, you have an extra leap month every 2 or 3 years, and that's how it worked traditionally. Right? Which seems barking to us, but actually, you know, it's a lot easier to say, well, there's another moon and add another one in and have someone tell you when to add one in.
I mean, I suppose we do have a leap year every 4 years. We have to add an extra day in to count for things. But
yeah, exactly. So the basic problem is the moon goes round the sun every almost 13 months. So the moon goes around the Earth almost every 13.
I was going to say, hold on, what?
And the Earth goes around the sun every 365 and a quarter days-ish.
Right.
So none of these things cycle up. So effectively, if you have a lunar cycle and a solar cycle, they don't mix.
Right.
Okay. So what used to happen, and I am not kidding you, what used to happen when there were 12 Christians in the world is the Pope would turn up and go, yeah, let's have Easter Sunday next week. And then everyone knew what it was. Okay.
So just the whim of the Pope would say, now's Easter.
Well, I guess he'd go outside and say, oh yeah, it's Passover, the moon's come up. Okay.
But that's exactly what they do in Islam, though, isn't it? You get people saying, I've seen the moon, therefore I proclaim Eid.
Yes.
It's exactly the same thing.
Exactly that. But officially, Easter has to be the first Sunday after the Paschal full moon, which is the first full moon on or after 21st of March, which is an approximation to the spring equinox.
Oh my goodness, that's just too much going on there.
Right. So the Pope used to say it's today. But now it becomes more complicated. And of course, we need to plan, right? We need to know when to buy our chocolate eggs several years in advance. We need to know when, to have our bank holidays. So for about the last 2,000 years, people have been arguing about the date of Easter. Right.
But
so
hang on.
Yeah.
Sorry, can I just ask a question?
Cool.
They're arguing about it, even though there seems to be a rule.
Right.
Like, but why are they arguing then?
Well,
because they think the rule ought to be different, the algorithm ought to be different, or because they can't do the maths.
Well, this is the thing. It's like, a recipe. Should we add salad cream or not? There are two different recipes there, and it's just where you argue over whether you should add salad cream or not. I assume that's how the Easter works. Yeah.
That's effectively right. It's when should we have our salad cream, and basically some of the early algorithms didn't quite know how many days it took the Earth to go around the sun, for example. So the date of Easter would get later and later, and eventually we'd have Easter in September. And I guess this is really important if you need to celebrate it on the same day as Jesus died in the Jewish calendar, which you have kind of incorporated into your own calendar. But basically, they've tried to make the algorithms as accurate as possible for predicting when the Pope would have come out of his house and gone, hello, it's after the equinox, all right? We have to link the sun and the moon together and try and predict when will be the first Sunday after the full moon, which occurs after the equinox.
Which occurred on the whim of a Pope.
No, that is what the Jewish law says is Passover. Right. So it's got to tie in with what is thought to be Passover. It isn't, but what is thought to be Passover when they invented this. Right. So
who calculates this next? So as you said, as we grew to know more about the sun and the moon, it's all very clockwork now. So we can do this to high accuracy. We can turn time. Because there was a really cool story about how they could track the Iliad based on what they said about stars, and they could wind back time and find out what the stars look like. And I can say that's when the Iliad was set. So so who is calculating this nowadays? Is it like the Met Office or something?
It's a very good question, and we're not actually using the position of the sun and the moon, even though we could. We're using. I'm not kidding you. We're using the late.
I feel like we're going deeper and deeper rabbit hole. You start on. Well, yes. How cool is this?
This is why I wanted to do this for 5 years.
This is going madness, utter madness.
We're using an Easter algorithm which was designed in 1800 by your favourite mind, Tom, Carl Friedrich Gauss.
Oh, Gauss. Got a little bit of Gauss.
Right.
Is this the same Gauss that is the person who invented Gaussian blur in Photoshop?
Yes, exactly him.
Okay.
Exactly him.
Photoshop.
Yeah. So I guess he was quite interested in, errors and things that moved around. So
the Gaussian blur is the normal distribution. That's what he was doing. So the idea is you find your mean and then you spread it out a bit, and that's your blur. That's the Gaussian distribution around your point.
Yeah. So he invented Photoshop and Easter in 1800.
You can see why I like him.
Well, actually, let me just run through the algorithm, and I'm going to do this once and once only.
So we take our age, we add the digits.
If only it were that simple. So you take the year,
right?
Divide it by.
Can we do this now? So let me.
No, we really can't, Tom.
Oh, right,
let's start. I wonder if you could do it. Yeah, let's do it. Okay, get your piece of paper.
I'm writing it down.
All right. So this is all on Wikipedia. You could also read it in its original German.
Nein, danke.
Or some. You do speak German, don't you?
Yeah.
Yeah, sehr gut. You should have read it.
Here we go. Right. So we take the current year.
Current year.
So it is 2023.
Yeah. divide it by 19 and take the remainder.
I'm already out. Goodbye.
We're going to call that A. We're going to take the current year, divide it by 4 and take the remainder.
So we've done by 19 and 4.
Yes. So A is the year divided by 19 with the remainder, which is 9, actually. We're going to take B, which is the year divided by 4 and take the remainder.
Okay,
which is 3.
3. So we've got 9 and 3. Okay.
Mhm.
And we're going to take the year divided by 7.
Oh my goodness.
We've not even started yet. You might have to fast forward this. And take the remainder, which of course is 0, because everyone knows 2023 is a multiple of 7.
Of course.
Ovs. Right. And then we're going to take the year and divide it by 100.
And take the remainder?
No, just that. So ignore any leftovers. We're going to take the floor of that. So just
okay. I can do that one. That's 2.
Yeah. 20 divided by 100.
Oh, sorry.
Yeah. Right. So we've got 9, 3. We've got 9, 3, 0, and 20.
Yes, we do. Okay.
And then we're going to take 13 and add 8 times the 20 we just calculated.
Oh my God.
8 times 20. Okay, so 8 times 20, that would be 400?
No, 160.
No, it's getting close, 160. I'm terrible at mental arithmetic.
Plus the 13, which gives us 173.
173, I got that one, yeah, okay.
Divide it by 25.
Oh, you've lost me. You've lost me.
It doesn't matter. Gives you 6.
Okay,
Take the 20 we calculated earlier and divide it by 4.
that's fine. I can do that
5.
one.
Right, then we, which I'm joking. We're going to take 15 and then subtract the 6 we calculated 2 steps ago, add the 20, and then subtract
9.
5
So
we calculated in the last step.
9 plus the 20 is 29. Plus 5 or minus
15 minus 6 plus 20 minus 5.
24.
Yes. And we would divide it by 30 and take the remainder, but that's just 24.
I've run out of space on my piece of paper.
We're only halfway through. We're only halfway through.
Oh my.
And there's another 5 steps like that, which are sort of what we call sort of modular arithmetic. So either take the remainder or take the whole number.
You know the thing is, does it tell you when Gauss came up with this? Because he was like 12 years old or something.
Right. So he did it when he was 1800.
Gott im Himmel.
1800. And apparently he got it wrong. And his student pointed out the flaw in 1816. So what are we doing here? Okay, basically, the first part we've done is working out how the moon goes around and round.
Right.
Okay? And the second part is saying, well, how far has the moon gone round when we stop the clock to calculate when the next Easter is? So how far after the equinox is it? So first bit does the moon, second bit does the sun, and then we put it all together. So the 13s were presumably there's 13 moons in a. I mean, for heaven's sake, okay?
Wow.
Absolutely ridiculous. Okay, and this will predict the date of Easter for any year. Okay, any year until somebody decides to stop using it. And it's horrible. Okay, but what it does is it tells us what day is going to be Easter. So Easter can fall any day between 22nd of March and 23rd of April. So we've got nearly an entire month to do it. So we've kind of got, when the first moon after the equinox is, and then we have to add a couple of days. I guess we've got 28, 29 plus 2 days, something like that. And apparently the most likely day for Easter is the 31st of March. 31st of March in the next, in the current time. So guess how long it takes before the cycle of Easters repeats?
It's going to be like once every, 5 years or something, isn't it? 4 or 5 years?
It could
Give
repeat.
or take.
Yeah, it could
Yeah,
be.
but I've no idea about the.
But yeah, when
pattern.
I'm going to guess millennium. Something ridiculously long.
Yeah, a few thousand years.
A few thousand years.
Yeah.
Millennium.
5,700,000 years.
Wow.
Right? 5,700,000 years. And I don't know, how long have humans been along for?
12 minutes.
I don't know.
Yeah,
Right.
but the thing is, I'm going to say, I'm not quite au fait with most of these holidays anyway. Like Pancake Day. I have no idea what that is. You could tell tomorrow is Pancake Day. I believe you. Fine, great. Essentially, BBC normally run an article saying, hey, here's how to make pancakes. Then I know.
Oh, but it's 40 days before Easter. So you just do the algorithm.
Yeah.
Yes.
So that's why I don't know when Pancake Day is, because it doesn't. Oh my God.
It's normally around my birthday, actually. It's quite fun to have a birthday on Pancake Day.
Oh.
Pancake birthday.
That would be quite nice, I imagine.
Hmm.
We've just had, is Robbie Burns night, is that fixed?
Yes.
Okay.
25th.
Right.
25th of Jan.
Like I say, again,
It's not lunar.
Right. So you probably have questions about this
no.
algorithm.
Why have they not just, like the guys at the Vatican, why have they not just gone and got together and gone, guys, this is ridiculous. Let's just sort it out once and for all.
Well, unfortunately, I've only told you half the story.
Ooh.
But
There's an Orthodox. The Orthodox people are completely different because they have their Christmas Day on the 6th of January.
that's right. And why do they have their Christmas Day on the 6th of January?
Because they go by the lunar system.
Ooh, not almost.
Oh, well, that's the Epiphany. So do they just like go, oh, that's when we're going to celebrate? I don't know.
That would be quite sensible. But unfortunately, they didn't do that. No, it's
Okay.
because the Christian churches, I can see Tom is despairing at the state of the word.
I know, it's because of the Grand Schism and they just wanted to be different.
Yeah, pretty much.
Is it?
Yeah, pretty much. It's because they're still using the Julian calendar.
Oh.
Okay.
Whereas we use the Gregorian calendar.
The Gregorian calendar.
Gregorian.
So the Julian calendar, which we abandoned in what, 17 something? I can't remember. But basically, they're still following a calendar which no one else uses just to calculate the dates of these religious festivals. Okay. So
Great.
let's
Good
talk
work,
about
guys. Good work.
There are people out there who've figured out how to work digital time. So every week, you'd have your 7 days, and every first would be a Monday, and for all the months, you'd have something like 13 months of this length. And
Tom. You know who tried that?
so beautiful. Because you go, I'll meet you on the 7th. You would immediately know it was the exact day every time.
You know who tried that? You know who tried a decimal week?
With Gauss, wasn't it?
It was about that time, actually, but it wasn't him.
Wasn't it? Okay.
Napoleon.
Yeah, of course it was.
But I have heard, I'll have to go check this, but I do believe that the person who ran Kodak when it was at the height of its powers,
Yes.
the guy tried to run his company on digital time.
Yes.
So
again, Napoleon tried to have a decimal week. So I don't know exactly how it worked, but I think you had 10 weeks, 10 days in a week, and an appropriate number of weeks in a year. But the problem is, of course, that doesn't go with the sun.
No.
Right. So, and the other thing is, what do you do? Like, you work 5 days, have 2 days off, and then have it just didn't work for people. Unfortunately, when we beat the Frenchies, we abandoned all any potential of that nonsense.
I'm astounded by this. I'm with Hannah. Just make it simple, guys.
Right.
It out.
So your question about the Easter was a good one. So why is the Julian one different? Surely it's similar. So what's the difference between the Julian calendar and the Gregorian calendar?
Does it have
Julius
extra months?
Put more months in or take some out because they were so far
It's
out. Right?
Sort of. So the difference between the Gregorian and the Julian is basically leap years. So which years are leap years? Hannah, over to you.
Every 4 years there's a leap year. There was, what was it, like there wasn't one in the year 2000 or something,
but
even
not
though
on a
they
millennium.
ought to have been.
Yes.
Is except when there's a millennium.
Yes.
Yes.
So yeah.
Almost, yeah.
Okay.
So centuries are not, except for ones that are every 400 years.
Right.
So 1600 is a leap year, 1700 isn't, 1800 isn't, 1900 isn't, 2000 is. And apart from that, it's every 4 years. So 2020, 2024. So,
okay.
So why is that done? Why is this done? Why do we have leap years?
Because the duration of the Earth's orbit around the sun is not precisely 365 days.
Yeah,
it's 365.2.
Yeah, exactly.
Yeah, 365.24219. Okay,
which means quarter, and we take that quarter every year and bang it on off every day.
Exactly. So by doing it every, not quite every 4 years and just adjusting it for these centuries, we get fairly close to 365.24219 days. Okay, so maybe many, many, many thousands of years we might have to add an extra leap day, but not very often. The Julian calendar does not do this, and it just has them every 4 years, right? So every 129 years, the Julian calendar gains a day.
Right.
So Easter, on average, because they use slightly different calculations, gets a day later every 129 years. And you might think that doesn't matter.
So do they have it on the same day every year, apart from when it kind of goes forward one day, or do they still have an algorithm? It's just a different day.
Good question. They have another algorithm.
Right.
Oh gosh.
But because we
will to live here.
Because they don't have the same complication with the leap years, and it's a slightly simpler cycle, it's only a 6-step algorithm.
Oh, praise be.
What really ticks me off about the calendar, being a mathematician,
yes,
the fact that September is not the 7th month, the fact that October, November, and December are not the 10th. It's the October should be, December should be 10, but the Romans screwed that up.
They did. Well, the Romans used to have extra sort of months as well. Like
just like rename them, call that dodecabury.
Yeah. Well, I mean, anyway, so I mean, our calendar is quite sane. It's probably as good as it can be, except for the stupidness of Easter, which varies about.
No, I'm all for decimal time. I forget all this decimal time.
But the Swiss actually did try to come up with decimal time, mostly as a way to sell watches. So I had a watch. I had a watch that went from 0 to 1,000, and the idea was that it was the same. You didn't change your clock, so it was 200 in New York, it was 200 in London, it was 200. It didn't catch on. Still got the watch. If Swatch want to sponsor a podcast, then Swatch are a really good watch company. If they don't, then buy Rolex.
Sorry, here's a question I feel like I ought to know the answer to, but have we always carved up time in that way? Like, does it go back to Romans? Were they measuring time in those fractions?
So we have sort of a base 60 time because of this goes back to Sumerians and Babylonians and things, because they used a year of 360, which was a nice divisible number. And this is why we have 360 degrees in a circle.
Ah, okay.
Because it's close to 365, but it's a nice number to work with because it's divisible by 1, 2, 3, 4, 5, 6, 8, 10. Well, yeah. So yeah, it's a nice number to work with, and so then 360 days, and then you break it up into 6. They had a base 60 system of counting, so 60 seconds in a minute, 60 minutes, blah blah blah.
Okay, so it's ancient.
Yeah.
It's really very old.
But I seem to remember that because they couldn't time things with accuracy, like the hours varied. So hours in summer were longer than hours in winter. So you just divided the day up in.
What is a second? Because I was reading into this the other day about what measures a unit, how the unit's defined, because now we're all very precise. And a second now comes down to the number of, it's like 420 electron transitions in a cesium atom.
Yeah.
Wow.
They redefined the SI unit, didn't they? So it's now vibrations of cesium. So I guess it's totally divorced from how long the Earth actually takes to go around the sun now.
Quite, yeah.
Gosh, things are confusing. Anyway, back to Easter.
When is Easter? Have we answered that question?
In which calendar?
This year. When is Easter this year?
Oh, but we're releasing this podcast, so it's now, isn't
it? It's today.
Whenever I release this, it's Easter. There we go.
Right. So, what would you do to fix this stupidity?
Just have it on the same Sunday after something every year. I don't know what the something is, because after the previous fixed date in the Christian calendar, such as 6th of January, Epiphany, that's the only one I can think of. I imagine there are many possibly minor things that are only celebrated in certain
here's how I would,
but I
would suggest spread your holidays out. So you take Christmas, you take what's the next big one? Bonfire night, Halloween. What's the middle of those two? Slap a holiday.
Or just have it as late in April as is possible every year to maximize your chance of having good weather on your Easter holiday.
Yes, I like that. Like the Queen's birthday. Oh.
Not bad. Yeah.
So, would it surprise you to know that there's an Act of Parliament which does exactly what you said?
Brilliant.
Yeah, it would.
What happened?
It would be, it's passed. It's on the statute books. The Easter Act 1928 would establish Easter Sunday as the Sunday following the second Saturday in April.
But can you do that as a kind of as a nation rather than doing it in a religious sense? Like, can you really go, I'm just going to proclaim this?
We have
religious holiday,
and I think that's essentially why it's never been enacted.
Yeah,
it passed the Commons, and all it requires is a resolution of both houses, and then His Majesty to sign it off, and it would happen, and all this silliness would go away. Gauss would disappear. All this Gregorian Julian nonsense would be rubbish. But of course,
yes, I suppose the monarch is the head of the church.
Yes, yes. So the last Pope promised to sort it out, never did, but basically no one can agree.
So when you say the last Pope, which do you mean here?
Benedict?
Gosh, no, Pope Francis. It was Pope Francis.
Right.
So he said he'd sort it out in 2015. Archbishop of Canterbury said, yeah, let's do it in 2016. We're all going to get together. Have they done it? Have they? Buggering hell. Okay, if humanity cannot agree on the date of Easter, we can't agree what day we're going to have little chocolate bunnies and, celebrate the death of some Jewish bloke or otherwise and eat chocolate. Like, how do we survive?
It's such low stakes, though. It's so complicated for something that's worthless.
Do you think most people would go for it in the country if we had a fixed day? Do you think people would prefer it?
Most people would know. So if you just said, Easter from now is going to be 30th of April, they go, yeah, fine.
It does make planning your life a bit easier, to be fair.
Yes. Well, I quite like a surprise holiday. Like it's quite nice to be spontaneous, right? And sometimes you're like, I've still got 2 weeks of teaching. No, you haven't. It's Easter.
It would make education a lot. It would make things a lot more straightforward for education, wouldn't it? And because you get these situations sometimes, especially with young children, where one of those terms will be really flipping long.
Yeah.
And that's like, and then that's, that's going to actually detrimental to kids' education, because like, you get into week 8 of a half term, they are just done.
Yeah.
But hear me out.
So you could avoid that.
I think Ben's got an idea. So New Year's Eve, we host a lottery where all the holidays are entered into Guinevere, and then we pull them. So like we'll say, when will Easter be? We generate 1 to 365. The number comes out of the lottery machine, and that's when Easter will be. That's where Christmas will be. That's
what if you had like it all on January the 2nd, January 3rd? What if you had all your holidays?
No. All the numbers would come out. You could have them consecutively. That would be, it's like January 3rd, 4th, 5th, 6th.
January, Good Friday, and you just have had Boxing Day the day before.
To be honest with you, if you live in Germany in May, that is basically your life, because there are so many Catholic holidays that are state holidays in Germany that you are literally off work for nearly all of May. It's bloody brilliant.
Yeah.
Right. So we all agree this is stupid, right? But why is it important?
Podcast or
no, the podcast has been stupid, but like the date of Easter, the algorithm, the maths behind it is ridiculous. But why is it important? Okay, well,
because it introduces chaos into our lives that we, love.
Yes, and specify what these rules are for very simple things is hard to do, right? So
I was actually joking.
Well, yeah, you're right. Okay, so let's do another thing. We're going to play some trolley car problems with you guys.
Oh,
Ooh.
so you're going to
And I'm going to ask for your opinion. Okay, and this is from Neil.fun, Absurd Trolley Problems. So, oh no, a trolley is heading towards 5 people. You can pull the lever to divert it to the other track, killing one person instead. What do you do? Pull the lever or do nothing?
Pull the lever.
Hannah?
Yeah. Pull the lever.
Pull the lever. Okay. There we go. And we've killed one person, but most people agree with you. 73% of people agree. A trolley is heading to 5 people. You can pull the lever to divert it to the other track, sacrificing yourself instead. What do you do?
Nothing. I like me. I don't know that those are 5 people.
I think this is where it gets kind of morally difficult, isn't it?
No, not in the slightest. Don't pull the lever.
So you kill 5 people, not yourself, or not do anything. Hannah,
kill them.
Depends who the 5 people are. If they're children.
binary choice, Hannah. Binary choice.
Okay. I think self-preservation kicks in. Do nothing.
Do nothing. All right, brilliant, excellent. 5 people dead. It's all your fault. Okay, so the point is, let's imagine you're programming a self-driving car.
I see.
Oh yes, this is the thing, isn't it? Yeah.
So, and you've got this problem. Okay, so you know you can either pull the brakes and probably kill the person who owns the car, okay, or you can hit the cyclist you're about to hit.
Oh, this is hideous. This makes me feel really funny.
I once heard an interview with a scientist who works at probably Tesla, and they were asked this question, how do you design an algorithm which chooses who to? Yeah. It was phrased as, the car has to, it's driving along, and in front of it there's a small child, to the left of it there's an old woman, and to the right of it there's a cat. It's going to hit one of them. Where does it go? Does it carry on driving? Does it swerve left? Does it swerve right? And they were asking the scientist this, and I thought the scientist gave actually a really good answer with, we haven't programmed the algorithm to do this because humans aren't asked to do this in their driving lessons. They will make us.
Okay. But we need.
There's no on your theory test. There's no trolley problem on there.
So we need to make.
But you expect the human to have some kind of moral compass that is unrelated to driving. So you don't need to teach it in a driving lesson, but you might need to teach it to a machine because they've not had the experience of
but as we saw,
growing up as a
humans have
human.
different moral compasses. So why would we assume a machine was any different?
True.
But what do? We have to program it somehow.
What does this have to do with Easter?
Well, the point is
algorithms. I think he's trying to get.
Yeah. So the way you program the computer to decide what to do is an algorithm. So you have to say, if you see this, do that. Okay. So if the year is divisible by 7, do
so
that.
a Tesla can calculate when Easter is.
Right.
Is that what we're saying?
So we don't even really understand how Easter is calculated. Okay? Humanity as a whole cannot even agree on the principles of how Easter is calculated. Some people don't even do Easter, right?
And so you're drawing a parallel with self-driving cars. If we can't get Easter right, how dare we program a car to drive?
I wouldn't go that far, but I was making an interesting analogy, which I hope that some of our listeners might enjoy.
We'll stroke our beards and ponder.
Yeah. But for example, if you commit a crime in certain states in the US, you now get sentenced, and basically you pop in all your details into a computer, how many brothers and sisters you have, where you live, how many crimes you've had before.
And it pops out what your sentence should be.
Right. And guess
However,
what?
they found out that they were hugely racist, though.
Hugely racist, right? So the same people who just happen to live in a black area as opposed to a white area, or generalizing there, and sorry for the terminology, but will do vastly different sentences.
This happened with the GCSE and A-level results as well in COVID.
Exactly right.
Yes.
Right. So people's futures
will lower will change it to what the average of your area would be in the previous years, which would any good students coming through, or it's absolutely ridiculous.
So people's futures are being, and this was a very simple algorithm. I think it probably had fewer than 13 steps. It was simpler than the Gauss's Easter algorithm. But and this is determining people's futures, right? So I guess the argument is, how comfortable do we feel with this? How comfortable do we feel with these often not spelt out sort of black box algorithms? How do we know they're doing the right thing? Are they serving humanity? And does anyone want another Easter egg?
Gosh, Ben, we started with funny Easter. Now we're
I love this. I could talk about this all night.
Gosh.
Right. I'll see you later. You
Hey, what do you think? What are your thoughts, Hannah?
Do you want my opinion?
Yeah.
I think life based on algorithms has the potential to undo quite a lot of progress, social progress that has been made.
Yeah.
Because it's kind of, I suppose, when you are building an algorithm based on majority views, majority kind of behaviors, they may not necessarily be correct.
Well, it quashes the
or kind or fair.
Yeah.
That's my take on it.
It also annoys me just at a very low level, on the everyday level, which is the computer says no mentality. That no algorithm can consider all the possibilities that it will be hit with. Whereas with a human, you can negotiate, you can question, you can say, what about, could we maybe think about what if? The computer, you put in your details and it comes out with 0 or 1 at the end of it. And that's the only answers it can possibly have. There is no negotiation there. There's no potential for understanding. And so
there's no nuance.
There's no nuance. No nuance.
Yeah, exactly. And this can go into things like healthcare, can't it? Insurance. You're already, there's already algorithms that will give you your insurance premium based on all these different factors.
They're all algorithmic. They're all algorithmic.
But if you and we accept that, don't we? We accept that, oh, okay, you know, I'm this age, therefore I'm going to pay less or more for my insurance. I know they've removed the gender part of it now, haven't they? But like, you know,
but I think they found they could actually pretty accurately predict your gender based on other things.
Yeah.
Oh, right.
I guess I'm just saying that we need to understand this a bit more, and we primarily need to do some fundamental mathematical research in order to.
I like the way you found the ending there, which is fund maths more.
Absolutely.
Right. So let's bring this on point. Let's bring this insanity to an end. Ben, could I have a random scale and a random point upon that scale of how you think your Easter will go?
I think it will be 9 out of 10. Excellent.
Hannah, can I have a random scaling and a random point upon that scaling? How you think your Easter will go?
I'm going to say it's going to be a healthy 7 out of 10, with the taking off the 3 for potential bad weather. Hoping it's going to be good weather. I think we're going to have a cracking time.
Oh.
Hey, very nice. And mine is going to be on a scale of I take a number, I divide it by 19, I then 4, and then I divide by 7, add all of those together, take the floor of it, and that is my score for what my Easter will be. I hate this. I despise it. I did not like this at all. That was horrible. But it was and upon that anger towards the calendar, I have been Thomas Woolley.
I've been Ben Parker.
And I've been Hannah.
And with that, thank you very much for listening to this absolute madness. We have been MathSat. Losing at life, certainly. Losing at maths, definitely. Good night.
Good night.
Bye.
Oh, God.
You have been watching Thomas Woolley, Ben Parker, and Hannah Veal. Intro and outro music was Clonky Donkey, and the incidental stings were Cartoon Bank Heist, all from YouTube Audio Library.